Alright guys, let's talk about rogue planets. They're basically the lone wolves of the galaxy. These are planets that have no star to orbit. They're just out there, drifting through space like cosmic hitchhikers. The big question is, could we live on one? It's a wild thought, but hey, let's break it down. So, what exactly is a rogue planet? Basically, it's a planet that doesn't orbit a star.
Whoa! Yankee with no...
It's either been kicked out of its solar system or formed on its own in the vastness of space. And yes, this actually happens. Planets can get gravitationally yeeted.
Here.
This is empty. Yeet!
Technical term, of course, during chaotic events like close encounters with other planets or stars. Now here's the crazy part. Rogue planets might actually be more common than you'd think. Some estimates suggest that there could be billions of them in the Milky Way alone. In fact, rogue planets might outnumber stars by up to 2 to 1. Think about that. There could be twice as many rogue planets as stars, and yet they're so faint and hard to find that they're like cosmic ninjas. Later in this video, we will talk about how we can find these rogue planets though. Now, what makes rogue planets so special? First off, without a star, you'd think they'd be ice-cold wastelands, and yeah, the surface would be freezing. But here's the twist. Some rogue planets might have a geothermal heat source, thanks to their cores still being hot. This internal heat could keep subsurface oceans liquid, and if there's water down there, that means there could be life. At least, that's what we hope. Alright, let's imagine we're setting up camp on a rogue planet. First problem, no sunlight. That means no photosynthesis, which is kind of a bummer for food production. We'd need to rely on artificial light or some crazy sci-fi farming tech like Matt Damon from The Martian or something. Second problem, heat. Without sunlight, the surface is a frozen wasteland, so we'd need to live underground, close to the planet's core, where geothermal energy could keep us warm. Personally, I wouldn't be opposed to being some sort of a space hobbit. I just have to go on an unexpected journey every once in a while. Okay, what about oxygen? A rogue planet's atmosphere is tricky. Without a star, there's no solar wind to replenish atmospheric particles. Over time, gases like oxygen could escape into space, leaving us gasping for air. So we'd need a way to artificially generate and maintain a breathable atmosphere. Maybe giant space domes, or, we could take a page from The Martian and just grow potatoes in a little bubble. Now, could life already be there? That's kind of the cool part. Some scientists think the rogue planets could already harbor life. If a planet has liquid water under its surface, microbial life could be chilling down there. Literally. It's kind of like the moon's Europa, or even like Saturn's moon, Enceladus, in our solar system. We haven't found life on rogue planets yet, but hey, the universe is full of surprises. Now, how do we find rogue planets? Finding rogue planets is one of the hardest challenges in astronomy because they don't have a star to light them up. They're essentially invisible in the vast darkness of space. So how do we find them? One of the most effective methods is called gravitational microlensing. It's pretty similar to gravitational lensing, and if you haven't seen my video on that, be sure to check it out. Here's how it works. According to Einstein's theory of general relativity, massive objects like planets bend the fabric of spacetime. When a rogue planet passes directly in front of a distant star from our perspective, its gravity acts like a lens, magnifying and distorting the light of that star. Astronomers use this brief brightening of the star, captured as a spike on a light curve, to infer the presence of a rogue planet. The duration of the spike can tell us the planet's mass. For instance, a low-mass planet might cause a lensing event that lasts a few hours, while a more massive object could create an event that lasts days. Now, this doesn't happen often. Microlensing events are rare and they require precise alignment between the rogue planet, distant star, and the Earth. That's why telescopes like the Vera C. Rubin Observatory are designed to monitor huge portions of the sky, increasing the chances of catching these fleeting events. The cool thing? With microlensing, we can detect rogue planets that are light years away, even if they don't emit any light on their own. It's like finding a needle in a haystack, while blindfolded in the middle of space. But, hey, astronomers love a good challenge. We're just like that. Maybe not. Anyway, could we live on a rogue planet? Let's discuss the final verdict. Technically, yes, we can. There are so many rogue planets out there that chances are one of them could harbor life. But realistically, it'd be insanely difficult to find one and eventually to live on one. You'd need advanced technology, underground habitats, artificial food production, and a way to generate oxygen. Basically, you'd have to build an entirely self-sufficient ecosystem. But here's the thing. Even if we can't live on a rogue planet, studying them helps us understand the extremes of habitability. These planets are a reminder that life could exist in the most unexpected places. So there you have it. Rogue planets are pretty lonely out there, but they're also weird, fascinating, and maybe even habitable under the right conditions. What do you think? Could you imagine living on one? Let me know in the comments what problems you might think would arise if we go and live on one. And also, as a bonus question, if you were selected to go to live on a rogue planet, what 3 inanimate things would you take to be with you? Let me know in the comments and keep expanding your universe, guys. See you next time. Don't forget to like and subscribe. It's free and you can change your mind at any point in time, and it really helps me out as well.